Welcome to Big Idea Test Review. This should be the third time going through this, so we should be getting along pretty well. If you're viewing this and you're outside of this class, you're viewing this for the first time, add comments. I can steer you to where I do this, particularly this graphing process. I refer to it as rubber stamping. All right, but most of you have been with me, so we're going to choose a value for x. I'm going to multiply that value by 2. I'm going to multiply that value by pi. I'm going to divide that value by 3. I'm going to subtract pi on 3 from that. And then I'm going to take the cosine, multiply by -1/2, and subtract 2. And this has really got about as much going on as you would ever see. So if you can handle this one, you definitely have the stamping process down. By the time I get done with the argument, by the time I subtract pi on 3 right here, I want these values to be 0, pi on 2, pi, 3/2 pi, and 2 pi, because I know the cosine values there. They go from 1 to 0 to -1 to 0 to 1, and that would be a rubber stamp for any cosine graph I'd have to do by hand. Then we multiply those values by -1/2. And then we add 2 to those values. 1.5. 2, 2.5. Did I say add? We subtract, sorry. -2.5, -2, -1.5, subtracting 2, -2, subtracting 2, -2.5. I should start over, but I need to get this done today. Okay, backwards we add pi on 3. I notice when I add pi on 3 to my fraction here, I'm going to have on 6. I'm going to have to go to common denominators. So I'm going to write everything in terms of 2/6. I'm really going to be adding 2 pi on 6 here rather than adding pi on 3. Same thing. So I get 2/6 pi. Let's see, that's 3/6 plus 2/6, 5/6 pi. 6/6 plus 2/6, 8/6 pi. Worth noting, I went up by 3, went up by 3. Hope that continues. 2/6 plus 9/6, 11/6 pi, and 2/6 plus 12/6, 14/6 pi. I'm going to multiply by 3, which is kind of nice because multiplying by 3 is going to just reduce the 6's in the denominator to 2's. So that's 2/2 pi, 5/2 pi, 8/2 pi, 11/2 pi, and 14/2 pi. I'm going to divide away pi. So 2/2, 5/2, 8/2, 11/2, 14/2, and I'm going to multiply by 1/2 to cancel the time, to reverse the times 2. So I get 2/4, 5/4, 8/4, 11/4, and 14/4. And I'm tempted to count by just 1/4 here, but I really don't have enough room unless I add more tick marks in here, so I'm going to count by 2/4. 2/4, 1. Let's see, 2, 4, 4, 6, 8, 10, 12/4. Out here we're at 14/4. I'm just going to write it as 14/4. Okay, so at 2/4, so that's every step is 2/4. 2/4, I'm down 2.5. Now I need to get to 5/2. 2, 4, 5/2, or 5/4, excuse me. 2/4, 4/4, 5/4. I'm down 2. 2, 4, 6, 8/4. I'm down 1.5. Pretty flat graph. Accentuate that a little bit. At 11/4, 2, 4, 6, 8, 10, 11, I'm back to my center line, -2. And at 14/4, I'm all the way down to our bottom, -2.5. So our cosine graph looks like this, although I didn't do the best job with it. And that's a full period, but I need to tie into the y-axis. So my next step over, if you take a look, I'm going 1.5 units between my increments, 1.5 of these little tick marks. So I need to go There's 1.5. My next little point, target point, would be right there. Okay, so there's a full period, and we got the y-axis. We could build more in as needed. Okay, number 2, a little bit kinder and gentler problem, except we're dealing with a cosecant graph, so we got to be careful there. Choose a value for x, multiply 4, add pi on 2. Take the sign, although you could build a cosecant stamp for this. Multiply -1, add 2. Once I'm done with my argument, adding pi on 2, I'd like these values to be 0, pi on 2, pi, 3/2 pi, and 2 pi. Sign goes from 0 to 1 to 0 to -1 to 0. Multiplying by -1, I get 0, -1, 0, 1, 0. Adding 2, I get 2, 1, 2, 3, 2. Reverse operation, negative pi on 2. Let's see, that works out. That works out nicely. So we get negative pi on 2, 0, pi on 2, 2/2 pi, and 4/2 minus 1, 3/2 pi. So again, we go from -1 to 0 to 1 to 2 to 3. Multiply by 1/4. Negative pi on 8, 0, pi on 8, 2/8 pi, and 3/8 pi. I think I'll just count by 1/8 pi. 1/8, 2/8, 3/8 pi, and negative pi on 8 here. Okay, now remember, these are sign values we get out of here. We'll go through that. I'm going to put those as dots, but I'm not going to draw the sine curve. At negative pi on 8, I'm up 2. At 0, we're up 1. At pi on 8, we're back up to 2. At 2/8, we're up to 3. And at 3/8, we're back down to our center line. But our center line points on sine identify our asymptotes of cosecant. So there is our curve. And now I had inadvertently skipped this. So let's go back up to part 1. Amplitude is 1/2, always positive. The period, I could try to figure it out here, but take a look. We go from 2/4 to 14/4. We covered 12/4 ground. That is just 12/4 or 3. The same thing we would get if we divided 2 pi by 2 pi on 3. We get exactly the same thing. Okay. Phase shift, 0 got shifted to 2/4 or 1/2. Our phase shift is positive 1/2, 1/2 to the right. That was our transformed initial point right there. And our center line is -2. For a cosecant graph, we don't typically talk about the amplitude. If you were to say that it was 1, I would say that's okay. Our period, we moved from negative pi on 8 to 3/8 pi. That's 4/8 pi or pi on 2. The same thing we would get if we took 2 pi and divided by 4. Our phase shift, our x value of 0, got shifted to negative pi on 8. And our center line is clear a lot of places, is y equals 2. Alrighty, tangent graph. I'm going to choose a value for x. I'm going to multiply it by 5. I'm going to subtract 2 pi. Big shift to the right. I'm going to take the tangent. I'm going to multiply it by 2. I'm going to add 1. And for the tangent graph, when I'm through with the argument, after I subtract 2 pi, I'd like this to be negative pi on 2, negative pi on 4, 0, pi on 2, or pi on 4, and pi on 2. Because tangent is neatly confined between asymptotes from negative pi on 2 to pi on 2. It goes to -1, 0, and 1. That's our stamp for tangent graphs. times 2, undefined, negative 2, 0, 2, undefined, plus 1, undefined, negative 1, 1, and 3. I need to add 2 pi. Let's see, I've got fourths here, so I'm going to add 8 fourths. Add 8 fourths, and I get 8 fourths minus 2 fourths. I get 6 fourths pi. 8 fourths minus 1 fourth, and I get 7 fourths pi. 8 fourths minus 0, 8 fourths pi. 8 fourths minus 1, 8 fourths plus 1 fourth, excuse me, 8 fourths plus 1 fourth, 9 fourths pi, and 8 fourths plus 2 fourths, 10 fourths pi for a nice steady increment. And then I need to multiply by, wait a minute, this was, hold on, x, divide 5, sorry. So I divided 5, so now I need to multiply by 5. Some of you are probably holding your breath, hoping I didn't miss that. Choose x, divide 5, subtract 2 pi. So now times 5, oh man, this is going to be a little bit inconvenient. I get 30 fourths pi, 35 fourths pi, 40 fourths pi, 45 fourths pi, and 50 fourths pi. Well, I got to get out to 50 fourths. Looks like maybe counting by 5 fourths might not be too bad because I'm on increments of 5. I think I'm going to do that. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. There's 50 fourths pi right there. Counting out by 5 fourths. A little bit of a mess, and we got some building to do. At 30 fourths pi, we're undefined. 5, 10, 15, 20, 25, 30, right here. And at 50, we're undefined. We've got an asymptote. At 35 fourths, we're at negative 1. At 40 fourths, we're at 1. At 45 fourths, we're at 3. And we look tangent curve like that. So let's build that back. Translate that point. Translate this point. Translate this point. Translate the asymptote. There's 2 full periods, which is good for some, but I always like the y-axis involved. Translate. Translate. And there we've got it. That's enough, but you may want to include that. Amplitude, nope. Period. Let's see, we went from 30 fourths to 50 fourths, traveled a distance of 20 fourths pi. Oh, that's just 5 pi. Same thing we get if we took tangents period pi and divided by 1/5. Phase shift, careful. 0 got turned into 40 fourths or 10 pi. 0 moved over to 10 pi. The phase shift is 10 pi. And the center line, y equals 1. Whew. All right, let's move on. Verify the following identity. Tangent squared plus 1. That's secant squared. Maybe I don't want to do that, but boy, that's just too tempting to pass up. Cosine squared minus 1. Well, I'm thinking sine squared of x plus cosine squared of x equals 1. Can I get 1 cosine squared minus 1? Yeah, if I subtracted 1 and subtracted sine, this is times negative sine squared of x. Let's go sines and cosines. This is 1 on cosine squared of x times negative sine squared of x on 1. That's negative sine squared of x on cosine squared of x. And that is negative tangent squared of x equals negative tangent squared of x. So not too bad if we recognize our Pythagoreans. Without that, it's going to be a bigger challenge. Okay, we want to find the angle from 0 to 2 pi where cosine is negative square root of 2 on 2. Well, cosine is the ratio x to r. X to r is negative when x is negative, and square root of 2 on 2, that's 45s. So we're right here at negative square root of 2 on 2. So from 0 to 2 pi, those are our two choices, but they tell us, oh, by the way, sine of that angle is less than 0. Whereas y on r less than 0, when y is less than 0, that's down. So we only want that angle. Sine's positive in the second quadrant. So 1/4, 2/4, 3/4, 4/4. Theta is 5/4 pi. All righty, well, these are quicker than the graphs. You're riding a four-wheeler in an open field. You start the trip by traveling 2.4 miles north. Make a left turn then. So I'm going to go 2.4 north. Make a left turn and travel 4.6 west. What bearing should you take to travel directly back to your starting point? So I want to do this. There's our angle back from due east. So I'm going to say this is east theta to the south. We want to rotate theta to the south of due east. So let's figure out theta. Tangent of theta is 2.4 on 4.6, so theta is tangent inverse of 2.4 on 4.6. And how could we miss this? We might miss this by not being, looking for my good calculator, I think somebody borrowed that, by not being in degrees. We need to be in degrees here. So I'm going to just go with, there it is. I'm in degrees, need to double check that. And now I'm going to go tangent inverse of 2.4 divided by 4.6. Before I do it, I might want to give some thought. What's a reasonable answer? This theta is definitely less than 45. It's opposite the smaller side. So I feel pretty good about that. We get theta equals 27.55. I'm going to say degrees for a final answer of east 27.55 degrees to the south. All right. Photographer's taking a stylish photo with a unique perspective by laying on the ground and looking at the top of the monument. The monument is 67 feet tall. And the angle of elevation from the photographer's camera to the top of the monument is 18.3 degrees. I don't think I'm small enough yet, but gives us an idea. 18.3 degrees. How far away from the monument is the photographer? X. Well, X should be quite a bit bigger than 67, but it looks like once again we're in tangent land here. Tangent of 18.3 degrees equals 67 on X. Multiply X to both sides. Divide tangent 18.3 degrees on both sides. And we should have it. And this value should be quite a bit bigger than 67. So let's see what we get here. 67 divided by tangent of 18.3, we get 202.6 feet, rounded to the nearest tenth. All righty. And let's continue. Hopefully I can get this done. I've got about block in about 10 minutes right now. I don't think this is too bad. Simplifying, three different trig functions. Let's go to sines and cosines. Cosine of x on sine of x times cosine of x. That gives me cosine squared of x on sine of x here. I think I would get common denominators, call this sine squared of x on sine squared of x. And we get, or sine squared of x on sine of x. Sorry, multiply by sine on sine. And I get 1 on sine of x, which is good, but best answer, cosecant x. Not bad. Tangent of x is the ratio negative square root of 3 on 1. That is y to x. When is y to x negative? When y or x, but not both, are negative. That happens here. Long y at negative 1 square root of 3 positive. And over here at negative square root of 3 and positive 1. All solutions then, I can do this with just one naming, and I'm just going to do this. I'm going to go negative pi on 3 plus multiple half revolutions. This would be the same as saying 2/3 pi plus multiple half revolutions. Okay. Number 10, a little bit unique in problem 3 compared to the ones we were doing, but here we got 5 rotations to consider. This should really be an x and not a theta. If I change that to 5x by multiplying by 5, 0 is less than or equal to 5x is less than, I really have to consider solutions through 10 pi or through 5 entire revolutions. But cosine x on r is in ratio negative 1 to 1 only right here. So we would say 5x equals pi and 3 pi and 5 pi and 7 pi. How many times should I spin around and hit that? 5 times. And 9 pi. Multiply both sides by 1/5, and we got our answers. X is pi on 5, 3/5 pi, pi, 7/5 pi, and 9/5 pi. Oh, I'm doing great on time on this back page. Okay, secant is 6/5. Cotangent is negative 3 on 1, and both are in quadrant 4. So here is angle x. Angle x in quadrant 4. Secant r to x. Not even trying to draw it to scale. R to x, 6 to 5. Quadrant 4. 36 minus 25, square root of 11, but it's down. I want to double check those. Here's angle y, also in the 4th quadrant. Cotangent, x to y, 3 to negative 1. Or negative 3 to 1, but it's in the 4th quadrant. 9 and 1/10, square root of 10. Cosine of a difference is cosine plus sine. So cosine x, 5, 6, times cosine y, 3 on square root of 10, plus sine x, negative square root of 11 on 6, sine y, negative 1 on square root of 10. And we get 15 plus square root of 11 on 6 square root of 10. Which I would accept, but maybe we'd want to multiply this by square root of 10 on square root of 10 to rationalize, and we get 15 square root of 10 plus square root of 110, all on 6 times 10, 60. And there we have our review. Let me know if there's anything I can help you with. Kind of right where I was when I took it the first time, about 22 minutes, 23 minutes in. You're going to have to be efficient on this. Good luck, and let me help.